You know, every single night, you close your eyes and you think everything just shuts down. But your brain? Oh, it's wide awake. It's buzzing with this incredibly complex secret symphony of electrical signals. It's basically writing a story in a language we're only just now starting to figure out. So today, let's get into the story of how a new kind of AI finally cracked the code.
I mean, really, have you ever stopped to think about what's going on in there? It's not just random static. Tucked away in those brainwaves are massive clues about our health, our memories, even the root causes of serious sleep disorders that affect millions and millions of people.
And look, this is way more than just scientific curiosity. For doctors and researchers, cracking this sleep code is absolutely essential. Our sleep is so vital to our health and our quality of life, and when it goes wrong, the consequences can be, well, they can be really serious.
So, what's the current game plan? How do doctors even begin to tackle this puzzle right now? Well, they have a tool. It's powerful for sure, but man, is it complicated. It's a mouthful. Polysomnography, or PSG for short. Basically, you spend a night in the lab hooked up to all these sensors that record everything, your brain waves, your eye movements, even your muscle activity. It gives doctors this absolute fire hose of data, a direct recording of your brain's story for the entire night.
But here's the catch. Here's the huge bottleneck. A highly trained human expert has to sit there and manually label every single 30-second chunk of that data for the whole night. As the researchers behind this study put it, the process is just incredibly inefficient, expensive, and frankly, it's a total slog. There had to be a better way.
So naturally, everyone looked to artificial intelligence. The dream was simple, right? Let's teach a machine to do all that heavy lifting, but do it instantly.
And this really lays out the classic problem they ran into. On one side, you've got the human experts. They're the gold standard, super accurate. On the other, you've got these early AI models. Yeah, they were fast and automated, but their accuracy, it was just way too low for any practical use in a clinic. They just weren't reliable enough, not even close.
Essentially, these first AIs were just thrown into the deep end. They were fed all of this raw, messy, complex brain signal data and were basically told, here, you figure it out. But the actual code of sleep, the important stuff, it was just getting completely lost in all that noise.
Okay, so this is where it gets really cool. This is the light bulb moment. Researchers realized that instead of just feeding the AI all that static, they needed to teach the actual language of sleep. And it turns out that language is written in frequencies.
So, quick refresher on how this works. According to the official standard, your sleep isn't just one big block of unconsciousness. Nope. It's actually a journey, a cycle through 5 very distinct stages. You go from being awake, down into lighter sleep, deeper sleep, the deepest sleep, and then into REM, which is where most of your dreaming happens. And check this out. This is the secret sauce. Each one of those 5 stages has a signature brainwave, a dominant frequency that acts like a unique fingerprint. When you're awake, it's alpha waves. When you're in that super deep sleep, it's these slow delta waves. See? This isn't just random noise. It's a clear, predictable pattern. This right here, this is the decoder key.
So yeah, this was the big aha moment. All of these super clear frequency patterns were right there in the data the whole time. But nobody was explicitly telling the AI, hey, look for this specific thing. It's kind of like asking someone to find a needle in a haystack without ever telling them what a needle looks like. All right, so a new team of researchers comes along and says, okay, let's stop making this so hard on the AI. Instead of just giving it a puzzle and hoping for the best, they decided to give it a roadmap. They built a smarter way for the AI to listen from the ground up.
Think about it this way. Imagine you're trying to listen to 5 different radio stations, all blasting out of a single crackly speaker at the exact same time. It would just be a chaotic mess, right? Well, that's basically the jumbled signal that the old AI models were struggling with.
The solution then is just so beautifully simple. What if you could filter out all that noise? What if you could give the AI 5 different sets of headphones, one tuned perfectly to each radio station? All of a sudden, that jumbled mess would become crystal clear.
And that is precisely what this new framework does. It's so elegant. Step 1, it takes that raw, noisy brain signal. Step 2, and this is the magic trick, it uses something called a band pass filter to split that signal into 4 clean, separate channels, one for each key frequency. And finally, step 3, it feeds those clean, organized channels right into the AI.
So the big question is, did it actually work? Was this new, smarter way of listening really any better? Oh yeah, the results are, well, they're staggering. 91.1%. Just let that number sink in for a second.
What that means is, simply by cleaning up the data first, by teaching the AI exactly what to listen for, the researchers achieved this massive leap in accuracy, correctly identifying the right sleep stage over 91% of the time.
And this chart really puts that into perspective. I mean, look at this. Previous studies were kind of stuck down here, around 82%. Even their own control group in this study, the AI using the old method, only got to about 85.5%. But their new method? It just blows them all away, jumping all the way up to 91.1.
And let's be super clear here. This wasn't just a little bit better. This was a new record. For this specific public data set that lots of people use, no one's ever done it better. They basically just set a whole new standard for the entire field.
And this is where it all really matters, right? This isn't just some cool academic exercise. A direct quote from the paper says it all. This framework could be a total game changer for helping doctors diagnose conditions like insomnia. Think about what that means: relieving a huge burden on sleep experts and, most importantly, getting answers to patients so much faster.
You know, it really goes to show you that sometimes the biggest breakthrough isn't just about building a bigger, more powerful algorithm. It's about teaching it how to listen in a smarter way. And it really makes you wonder, doesn't it? As we get better and better at decoding all these hidden languages our bodies are speaking, from our brainwaves to our heartbeats, what other secrets are just waiting for us to find the right way to listen?